Hello and welcome to Math with Lou. Today we are going to be talking about solving equations. We are going to get into the bread and butter of algebra, which is solving for our unknown variable x. Alright, let's dive right in. So, solving equations. So I start off with a basic example so we could build up to how we could do this algebraically, but we're going to look at it without any algebra skills for now. So we have this problem. A book club requires a membership fee of $20 plus an additional $5 for each book ordered. Okay, so we can model this. We have enough information to give this an equation, and we're going to look at how much the total cost comes out to with each individual case. So when we have one book, so we have the $20 plus the additional $5 for the number of books ordered, which is 1. So 20 plus 5 times our one book, 20 plus 5, $25. So if you join the book club and you guys only read one book, it's going to cost you $20 to sign up for the club, plus that $5 for the one book, $25. And then we can keep going to find out what our cost is at different numbers of books. If we have 2 books in our book club, our now equation is 20 plus 5 times 2, $30. 3 books, 20 plus 5 times 3, 20 plus 15, $35. 4 books, 20 plus 5 times 4, 20 plus 20, $40. And 5 books, 20 plus 5 books times $5, 20 plus 25, $45. So now, from this we can come up with what we call a general equation. A general equation is an equation that utilizes variables that we can apply to any number, but we must be specific about that number. When we're not specific about that number, again, we call that number our variable. So when we have x books, an unknown number of books, that doesn't matter, our general equation is 20 plus 5x, 5 per 5 dollars per our x number of books. And then we can have this, we can come up with an even more generalized equation. C for the cost equals 5x, $5 times the number of books plus our $20 fee. C equals 5x plus 20. So small quick comment to make. Over here, you notice I called it 20 plus 5x, and then I rewrote it 5x plus 20 over here. We should know, thanks to the commutative property of addition, the order does not matter, but I like to personally put the term with the variable first. I think it looks nicer, and as we go into variables with higher exponents, it just becomes good practice to, again, puts the variable with the highest exponent first. All right, so let's move on. Now, if we want to figure out how many books we may get from the book club for $100, we have 2 options here. We can continue filling out the table until we find the x for c equals 100, which we left off at 45, so that getting up to c equals 100 would take a while, and we don't want to do that. Or alternatively, we can use the properties of equations. Okay, and here's how we can go about this. So here is the original equation that we started off with. C equals 5x plus 20. Got that equation from right here. Now the first step is to substitute C for $100. So that's what I do right here. I rewrite the equation. Instead of C, I put 100. And the reason that C is replaced with 100 is, again, because we want to find out how many books it would take for the total price to reach $100. So from here, we now start just applying the rules that we talked about. First, we can get rid of the 20 that is being added to the 5x by subtracting 20 from both sides of the equation. 20 minus 20 is going to give us a 0 here. So, and then 100 minus 20 is going to give us 80. So now we have our new expression, 80 equals 5x. And now from here, we must isolate x, and we can simply do so by dividing both sides by 5. And we divide by 5 because division is the inverse of multiplication. Since we are multiplying 5 here, we must divide 5 to get x by itself. So once we divide each side by 5, we get x equals 16, which tells us that after 16 books purchased, the fee for the book club will be $100. When we want to solve an equation for one unknown variable, as x in the example above, The goal is always to isolate the unknown variable. Again, when we are solving for a variable, we must get it all by itself on the equal side. Here, we were looking for x. We're not looking for 5x. We got to divide to get alone. We just want 1x. You could say that we put everything on the other side of the equal sign. This is very common terminology, math lingo used. You want to get everything to one side of the equal sign so you have x all alone on the other. It is always a good idea to add or subtract away any constants before multiplying or dividing away the coefficient in front of the variable. All right, so I want to talk about that in the context of this problem here. This is the coefficient multiplying this variable, and this is the constant being added to this term. It is always a lot easier to get rid of any constants with no variables attached first. I will show you an example where we don't have to necessarily do it that way, and there are some times where it is advantageous to do it that way, but 90% of the time you want to get rid of any constants you can first so that we have the x terms all alone on one side, and then we isolate the x from there. As long as you do the same thing to both sides of the equal sign, you could do whatever you want in any order. And again, I'm going to build on these last two things that I mentioned here. We're going to build on this in this example here. So here I have the same example written out twice, and we're going to discuss both ways to isolate x here. So in the first method, I begin by dividing both sides of the equation by 4. And the reason I pick the number 4 is because the coefficient in front of our variable is a 4. That's where this 4 came from, again, from the coefficient in front of our x. So when I divide the entire equation by 4, a very common mistake that I see a lot with students, something I want to make very clear here, we are not just dividing this by 4, but the entire thing, which means the 20 is divided by 4, then we rewrite the plus, and then also the 4x divided by 4. And then whatever we do to one side of the equation, we must do to the other. So we have the 40 divided by 4 over here. From here, we just start simplifying what this comes out to. 4 over 4 gives us this 1. Rewrite the plus. 20 divided by 4 is 5. 40 divided by 4 is 10. So that's how we get this new expression over here. 10 equals 5 plus x. And now from here, we can subtract away the constant of 5. The opposite of 5 is negative 5. Combining those makes this a 0. Whatever we do to one side must do to the other. 10 minus 5 is 5. And here we get the final answer of x equals 5. And here's the other way we can do this. Now, in this method, again, this is what I would normally recommend doing. Start by getting the constant term away from the side of the equation with the x. So I'm going to start by subtracting 20 from both sides. 20, the opposite of a positive 20 is a negative 20. This becomes 0, which is what we want. And then we have 40 minus 20 over here, which gives us this 20 right here. So now we have our new expression, 20 equals 4x. And from here, we divide both sides by 4 because we're multiplying the variable by 4. Divide over here by 4, divide over here by 4, and we get the same answer as over here, x equals 5. Two different ways to solve, same answer. And when we solve things with different methods and get the same answer, that's always a good sign. All right, so here I have another example, and this one's a little bit bigger, but just because it's bigger doesn't mean it's any more difficult. 6x plus 15 plus 4x plus 8 equals 57. We have variable terms with coefficients all over the place, and we have constants all over the place here. So the first thing we want to do is group the like terms together so that we can combine them. Here, our like terms are 6x and 4x because they both share the variable x. They are like terms. And over here, our like terms are 15 and 8 because they are both constants. So now we can combine these. 6x plus 6x plus 4x gives me 10x. And then 15 plus 8 gives me 27. So now that we have an expression with just one term with the variable x, we're going to start isolating it. We start isolating it by getting rid of the constant on the same side of our equation with our variable x. So we subtract 27. Oh, this is going to bother me. There we go. Can't believe I forgot that. Anyway, we subtract the 27 from both sides, and now we are left with our new expression 10x equals 30. 10 is multiplying our variable x. To undo multiplication, we use division, so we're going to divide both sides by 10. This makes a 1. 30 divided by 10 is 3, and we get our final answer of x equals 3. Okay. If this is something you will see coming up a lot in algebra, so If you have an equation where you have variables on both sides, you basically do the same thing. We're just following the same exact steps here. You collect all of the like terms, collect all of the constants on one side of the equal sign, and all of the variable terms on the other. So here's my example. We have 4x plus 3 equals 2x plus 11. As you can see with this example, we have x's on the left and the right side of the equation. So the first thing I'm going to do is subtract the 2x from both sides. Now, I chose to pick the 2x to subtract from both sides. You are free to pick either the 2x or the 4x. Personally, I chose the 2x because by subtracting the 2x from both sides, we're going to have a positive number over here, which I like dealing with positive numbers better. If you subtract 4x from both sides, then you would have the 2x minus 4x equals negative 2x over here. And like I said, I generally try to avoid negatives, so I picked the 2x. So we're going to bring the x's to the left side, subtract 2x from both sides, and now we have 4 minus 2 is 2. 2x plus 3 equals 11. Just rewrite the expression with our simplified x's. From here, we want to get this all alone on the left side of the equal sign, so we're going to get rid of the 3. And the inverse of a positive 3 is a negative 3. We subtract 3 from both sides. Once we get to here, we now have 11 minus 3 is 8. So 2x now equals 8. To get our x alone, the x is being multiplied by 2. The inverse of multiplication is division. We divide by 2 to get rid of our coefficient. 2 divided by 2 gives us 1x here, and then 8 divided by 2 is 4. We get our final solution of x equals 4. And down here I have one last example written out. This one I did not work on yet because I was hoping we could do this one together. So let's dive right in. Now, the big difference between this one and the other ones that we have seen so far is that this one now has 3 times the quantity of x plus 2 in parentheses here. Now, we cannot do anything to this x plus 2 here until the 3 is distributed inside these parentheses. We can't subtract x, we can't subtract 2, we must drop these parentheses first, and again, the only way we can do that is to distribute the 3. So we're going to start with that. We're going to distribute the 3 into both of the terms inside my parentheses. 3 goes into x, and 3 goes into positive 2. So now, after distributing the 3 there, we can write our new expression. 3x, 3 times 2 is 6, plus 6, minus 3, plus x, plus 17 equals 40. Okay. From here, I'm going to start grouping my like terms together to make it easier on the eyes to see what will be combined. So I'm going to put these in parentheses again, just to make it a little bit easier on the eyes. So now, parenthesis, we're going to put the x terms in here. So we have our 3x from there, and then our plus x. And we're going to close our parentheses. Plus, and I'm going to do this one in, we'll do purple. Now my constant terms will go in here. And something I want to make very clear when we talk about these. Notice, for example, this negative in front of the 3. This reads 6 minus 3. This negative is glued to this 3. We cannot arbitrarily turn this into a positive 3. This is a negative 3. So again, the minus sticks with this. So let's start rewriting constants. We have the 6, the minus 3, and the positive 17. So we're going to write that as 6 minus 3 plus 17. And the 40 does not go anywhere. This is all equal to 40. Okay, so let's focus over here. Let's combine these x's. 3x plus 1x. This gives us now 4x's. And now we can start combining our constants over here. 6 minus 3 gives us a positive 3. Positive 3 plus 17 equals positive 20. So now we have 4x plus 20 equals 40. Something much cleaner, much easier to manage. Now we want to get rid of the constant term. So we're going to minus the 20 on both sides. For x equals 20. And now to get rid of the 4 that is multiplying the x, we will divide both sides by 4. And we get our final solution, x equals 5. Alrighty, and that is it for today, or at least for this video. Thank you for joining me. As always, the notes will be in the description, and I will see you next time. Take care.